So the purpose that we prepared these different solutions for really boils down to when you're working with an unknown protein. You have no clue what the concentration of that protein is in a given solution. So we use a Bradford assay to kind of determine roughly what the concentration is. But there are some instances where you might be working with a protein that is too concentrated, or the amount of protein in that solution is higher than what you find in your standard curve, in your line of best fit. So what do you do in that case? What you do is you make a dilution. So the dilutions that I just made, those were of my known protein being pancreatin. I know approximately what the concentration of this dilution 1 is because it's 1 part stock, which is 10 micrograms per microliter, and 1 part deionized water. And those are equal parts. So, spoiler alert, dilution number 1's concentration is approximately 5 micrograms per microliter. How do I know that? Because my stock concentration was 10 micrograms per microliter. Okay, so if dilution number 1 is 5 micrograms per microliter, what do you think dilution number 2 is? This is 1 part dilution 1 and 1 part deionized water. Well, this is going to be about 2.5 micrograms per microliter. So when you're working with an unknown protein, however, you have no clue what the concentration is going to be. And whenever you measure that concentration, if it's extremely high or extremely low, it might fall outside of the boundaries of the Bradford assay that you previously did. And so what we're doing here is we are going to take an unknown protein sample and take 100 microliters of it, mix it with the Bradford reagent, and determine the absorbance of that sample. Okay. If that absorbance is higher than our highest known protein sample, we have to make a dilution of that. We have to make a dilution and then kind of work backwards and say, okay, well, it's 1 part this, 1 part this. What is my concentration? The most important part of any Bradford assay is understanding your linear range of your line of best fit. If something falls outside of the linear range, well, then you can't really predict what the concentration is based on the absorbance of that sample. So what you're going to do is you're going to do a series of dilutions, and maybe you'll do 2, maybe you'll do 1, but you'll do a number of different dilutions and determine based on the absorbance of that dilution what approximately is the undiluted unknown protein sample's concentration.